Hello, this is Keith Graham from Codasip. I like to review Assignment 9, Checkpoint 1, validating your LUI and AUIPC instructions. Now let's go to Codasip Studio. You will be using a test program that you will import called the LUI AUIPC assembly test. Similar to past tests, there are two sets of comments. One set that's farther to the right, which describes what that instruction will perform, then a set of comments further to the left, which will notify you what changes will be occurring in the register value so that you can validate that your cycle accurate model is performing as expected. Now I'm going to launch this test program with my CA model. I have my register file view here. The first part of this assembly test is just setting some test data so that I can actually perform my test. And then you can see the very first part here is going to evaluate your LUI instruction. There are a couple of key points to take a look at to know whether your LUI instruction has performed correctly, and if not, maybe a hint on what might be incorrect. Now let's take a look. I got my first test point right here, which is line 39, so I'm going to just resume to 39. And basically says x5 should not equal x12. Or, so branch if they're not. They should be equal. So 5 is A5A, 5A. That matches 12. Now, it says basically it is validating that the upper 20 bits loaded correctly, which we can see is the value up here in 12. And then 5, I made all ones. And so which means that the lower, all 32 bits are ones. And part of the LUI instruction is to load the immediate in the upper 20 bits, but also clear out the lower 12 bits. So if the lower 12 bits were not cleared out, I would have a branch because 5 would not be equal to 12. So this is validating that the upper 20 bits were loaded incorrectly and that the lower 12 bits were cleared. So if you do branch, you can actually just take a look at, did I get the upper 20 bits correctly? If so, did I not clear the lower 12 bits? So we'll help you to debug your actual cycle accurate model. Now if we come down to the AUIPC, we got 2 test points. So let me go to the first one. Now let's take a look at the first test point here. What I'm trying to do in this test is my first part of AUIPC, I'm actually loading the upper 20 bits just like I do in my LUIC operation into X8. Then my combination of lines 48 and 49, I'm actually taking the label, and the label is the address at line 51. I'm loading it into my register X9, then I'm bringing it down to my lower bits. So I'm aligning it to my bit 0 location. So in register X8, I have the upper 20 bits in the right location. And now in the X9, I have my PC right justified. Now, if I properly do AUIPC, I'm taking that load immediate and adding it with my PC. So I have the combination of upper immediate plus PC. Now the subtraction here is I'm taking that combination of AUIPC plus the PC address, and then I'm subtracting X9, which is the PC. So I should be left with the value of the upper 20 bits immediate in register X7. If the upper immediate does not have the correct value, that means I'm either not properly bringing in the 20-bit immediate or the proper PC address and performing the operation. So at this point, X7 does equal my upper immediate as expected. So that means I've at least brought in the upper 20 bits correct. Now if I go to the next test point, I'm doing the same operation, but this time it's I'm validating that AUIPC, which is the upper 20 bits, plus the PC address. Now I'm subtracting the upper 20 bits. So it's upper 20 bits plus PC minus upper 20 bits. I should have the PC address. If the PC address is not equal, then I know that I've done something incorrect in gathering the PC address. Now we're taking a look at, do these things, does this address equal? For example, branch if x7 does not equal the combination of upper address plus PC minus upper immediate plus PC minus upper immediate, which is the PC address. So I'm just validating here that that is true. And if that is true, I know that I've properly implemented my AUIPC and I can go on to the next part of this assignment. If you enjoyed this video, please subscribe to this channel so you'll be notified on future videos when they are added. Good luck!